285. How can I use isosceles triangle properties to find side lengths and angle measures? How can I use isosceles triangle properties to find side lengths and angle measures? Y'all remember anything about an isosceles triangle? Go ahead.
It has two congruent angles.
It's got two congruent sides, first of all. Okay? And those two congruent sides are called, those are called legs. The other side in the triangle is called the base. The angle formed by the two legs is called the vertex angle. The other two angles are called base angles. In an isosceles triangle, if you got two sides that are congruent, then the angles opposite those sides are also congruent. So these base angles are congruent. All right, and that's isosceles triangle theorem. If two sides of a triangle are congruent, then the angles opposite those sides are congruent. If two sides of a triangle are congruent, then the angles opposite those sides are congruent. The converse of that theorem is right below it. If two angles of a triangle are congruent, then the sides opposite those angles are congruent. All right, so understand both of those. If two sides are congruent, then the angles opposite those are congruent. If you get a triangle and you're told that two angles in the triangle are congruent, all right, if angle A is congruent to angle B, then the sides opposite those angles. What's the side opposite angle B? AC, good. That side is congruent to, what's the side opposite angle A? CB. Those two are congruent. The theorem works both ways. If two sides are congruent, the angles opposite are congruent. If two angles are congruent, then the sides opposite those angles are congruent. So if you look at this diagram, ABCD? If you're told that AC is congruent to AB, then what angles are congruent in that picture? Angle B is congruent to angle ACB. Remember, guys, when you've got a vertex or a point that's a vertex in two angles, you got to use more than one letter to describe that angle. Can't call this angle C because it's the vertex for angle ACB and for angle ACD. If you're told that angle D is congruent to angle ACD, then what sides are congruent? And AD, good. Those sides are congruent. Everybody okay with that? Look at, draw you an isosceles triangle. It looks something like that. We'll label it PMN. Make angle P congruent to angle M. Angle N is 120 degrees. And side MN is 11. You're asked to find the measure of angle M. The measure of angle M. And you're asked to find PN. If angle P is congruent to angle M, what do you know about the two sides? MN is congruent to PN. So, what's the length of PN? 11, good. Now you got angle P is congruent to angle M, and you got to find a missing angle measure. Call these angles something. You can call them, if you call this angle A, what do you got to call this? Or if you label it A, okay? And these two are congruent, then angle M has to be labeled A. So how many A's do you have? You got 2A plus 120 has to equal 180. Good. Subtract your 120. So 2A equals 60. Divide by 2. And A equals 30. So the measure of angle M would be 30 degrees. Yes, sir.
Wouldn't M and N form a line, so it'd be 180 minus 120?
Wouldn't what?
Angles M and N, wouldn't they like form a line, so it would be 80 minus 120?
I don't think so. These three angles, that one, and that one, all have to add up to 180. And these two are equal to each other. So you got two that are equal to each other, plus the third one, the 120. The sum of those two is 180. So that's your setup. I mean, you could have subtracted 120 from 180 and said, all right, I've only got 60 degrees left, and these two A's have to add up to 60 degrees. But that ended up being the second step here anyway. All right, let's talk about an equilateral triangle. Equilateral triangle. A triangle is equilateral. A triangle is equilateral if and only if it is equiangular. Y'all remember what equilateral means? All sides are the same. And equal angular means?
All angles are the same.
All the angles are the same. Very good. If all the angles are the same, what does each have to equal? Very good, 60. So if all these sides are the same, then all of these angles are the same. And if it's a triangle and all the angles are the same, then they each equal 60 degrees. Any questions there? All right, so draw you this triangle. Let's make this 80, and those two sides congruent. 6x plus 8, 4y minus 2, 2y plus 2. And we got to find the value of each variable. Okay, do you guys see these congruent sides here? What do you know about angles opposite congruent sides? Angles opposite congruent sides are congruent. So this angle equals this angle, doesn't it? What do those two angles have to add up to? What do those two angles have to add up to? 100. Because you've already got 80 up here in the top. So 2 times an angle has to equal 100. So what does each angle equal? Each angle, I divided by A instead of, each angle has to equal 50. So what does 6x plus 8 have to equal? Good, 6x plus 8 has to equal 50. Subtract 8 from each side. And 6x equals 42. Divide each side by 6. And x equals 7. So these congruent marks give you a lot of information. They tell you that the angles opposite those are congruent. Okay? What do you know about the 4y minus 2 and the 2y plus 2? They're congruent, aren't they? So your 4y minus 2 is equal to your 2y plus 2. You're going to add 2 to each side. So 4y equals 2y plus 4. Subtract 2y. 2y equals 4. And divide each side by 2. So y equals 2. Does anybody have any questions?